what the characteristics are of sine and cosine graphs. Hopefully this is just a review, but here they are. So first we're going to take a look at some graphs. It's important to pay attention to the colors here. So green is an unmodified sine graph. And if you take a look at this 2, which we know to be a vertical stretch, so this would be like y equals 2 times sine of x, notice what it does. It stretches it away from the axis. That is, it takes all the normal sine values and multiplies each of them by 2, increasing how high and how low it goes. So as where it normally goes as high and low as 1, it's now going as high as 2 and as low as negative 2. And now we see normally, or a lot of the times, a horizontal stretch, which is what this is, would not be noticeable. But I think you'll notice here that there is a difference when we're talking sine. So sine is in green, and then sine 2x is actually here in purple. So if you take a careful look, you'll see that from 0 to 2 pi, sine has gone around once. That is full circle, right? What does this do? Well, it turns out that this is pretty obvious that it looks like a spring. We've compressed it, right? So this is a compression by a factor of 2. So what does that mean? It means that instead of taking 2 pi units, 2 pi of an angle, to go around once, it's now going around, well, let's take a look. It's going around once, twice. So it's going on twice in the same space. So the one in purple is going on 2 times in the same space, whereas sine takes 2 pi to go around once, right? Sine 2x only takes pi radians, right, to go around once, because if you look at one complete circle, right, it's sitting there at pi. Pretty straightforward, taking the sine, adding 3. In this case, it's a vertical shift. So subtracting 3 would drop it. Notice what changes. Whereas normally this is at 0, it's now at 3. Whereas normally this is at 1, now it's at 4. So it affects the how high and how low it goes, as well as what we'd call this line here kind of, well, we have a special term for it we're going to find out about in a sec, right? But if you look, it's symmetric vertically about this line here, as sine has always been, right? And last but not least is, well, this represents, remember, if this were f of x, this would be f of x minus pi over 2. So this would be a shift right of pi over 2 units. So if you take a look where 0 normally is, 0 is now pi over 2 units that away. It's like we took this green sine and we shifted it, indeed, pi over 2 units that away. Okay? So this represents a horizontal shift in the graph. Okay? So all these things have different names, which you hopefully remember, but if you don't, there's such thing as the amplitude, which is a vertical stretch, how high and how low it goes based on where it's centered. There's the period, which is the horizontal stretch, that is how often it's repeating itself. And then the midline, also known as the average, which is the vertical shift. So the midline would be that center, that horizontal center of the graph. And then the phase shift, which is a fancy name for the horizontal shift. Okay? And this has to do, the idea of the phase shift has to do with the fact that we often see sounds exhibiting these types of shifts, and so we're talking about shifting the phase of the sound. That's where that term comes from, but it's just a horizontal shift in the graph. So how is this reflected in the actual equation? So for sine or cosine, you'll notice the a, b, c, and d all represent the same thing. We'd have a, that would represent the vertical shift or the amplitude. Okay. The b tells us the period, or how often this thing repeats itself. B is equal to 2 pi divided by the period of the graph. That is, how often it's repeating itself. Okay. So under normal circumstances, if b were 1, right, if we're talking sine x, right, then we want the period to be equal to 2 pi, so 2 pi divided by 1. When we doubled it, we put 2 in there, so we made b equal to 2. Then, by the way, if we solve this, I should probably mention, everyone here is, of course, an algebra expert, right? It does mean that the period can be found, if we know the b, by taking 2 pi divided by whatever the b is, right? And we'll see this in examples too. But either way, this b tells us the period. Now please note, this b is has been factored out of whatever this x minus c is. And I have an example of why that's important. And this represents the phase shift, or the horizontal shift. Phase shift. Where if it's a positive number, it's going to be shifting right. And if it's a negative number, it's going to be shifting left. And last but not least, D represents the vertical shift, aka the midline. Or depending on what we're measuring, it could be the average. Okay. So if you think about averages, like an average temperature, it's going to have some variation in there. The average would be the middle, or the midline of that. Okay. So some things to remember. Sine 2x, right? Sine 2x is repeating itself more frequently, right? So sine 2x is this green graph, okay? So that's just repeating itself more frequently. And if you look, it's starting at 0. It's going around in full circle, right? Because we know that b is equal to 2, which means that the period is equal to 2 pi over 2, aka pi radians, right? Now both of these have the same value of b, but notice how that this is written, okay? Now I've shifted this red one up 2 so you can tell the difference, but if you look at the purple graph and the red graph, the only difference is the plus 2. In other words, these two graphs, the sine of 2 times quantity x minus pi over 4 and 2x minus pi over 2, if you compare these two, they look different, but it turns out they have exactly the same shift. So this has been shifted pi over 4 units to the right. So if you start at your green and you go pi over 4 over, so that's negative, 3 pi over 2, 2 pi over 2. Maybe an easier way to see this. What's halfway between 0 and pi over 2? Why, pi over 4, right? Pi over 4, which is here. Where this is pi over 4, it's now pi over 2, or pi over 4 units to the right. Here's why this works. If you take 2 times x minus pi over 4, that equals 2x minus 2 pi over 4, which is the same as 2x minus pi over 2. The reason that this is important is because often you'll see these things written such that it's been distributed. If you want to detect the actual horizontal shift, which is not pi over 2 in this case, it's pi over 4, you need to factor out this. So if you see it written in this form where it's not already factored out, you need to factor it out. So if you had something that was, let's say, 3x minus pi over 6, that is not, sorry, let's say this is, right? We could figure out the period, but we'd want to rewrite it so it was factored, right? Now when we're dividing out this. So what is pi over 6 divided by 3? Now that would be pi over 18. So pi over 6 divided by 3 is the, welcome back to fractions, pi over 6 times the reciprocal, aka pi over 18. So what this would tell you is, if it's written like this is actually, because you have to factor it out, a pi over 18 shift. Okay? And that concludes the basic characteristics of sine and cosine graphs.